Hello, this is we are still in redox titration, and this lesson is the second phase of redox titration. So we have this question: 10 gram of potassium magnate 7, 10 gram of potassium magnate 7 contains 250 centimeter cubic of liquid and label as solution A. So we have 8 gram of ammonium iron 2 sulfate, which contains 100 centimeter cubic, label as solution B. Then we have the procedure. The procedure is saying that fill the burette with potassium magnate 7. Then you pipette 25 centimeter cubic of solution B. Then you place in a clean conical flask. Then you carry out titration. This is now first titer, second titer, third titer. First titer 15.0, 15.0, 15.0. So the initial volume 0.0, 0.0, 0.0. Volume of solution I used 15, 15, 15. So when you get such, then you are supposed to carry out the calculation. So let us see the calculation. The first question, here we have question A up to J. First question is asking calculate average volume of solution A used. To calculate the average volume, you add all these 15.0, 15.0, 15.0. Then since they are 1, 2, 3, they are 3 in number, you divide by 3. So 15.0, 15, 15, then divide by 3. When you add 15, 15, 15, 15, you will get 75. Then you divide 3. Then you will get 15 centimeter cubic. This is the volume of solution A used. Solution A used. Okay, that is how you calculate A. So we have B, the concentration in gram per liter of solution A. To calculate the concentration in gram per liter of solution A, what do we have? Solution A, we have the mass, which is 10 gram. We also have the total volume here. Total volume 250. Then 10 gram is equal to 250. What about 1000? What about 1000? 10 gram is equal to 250. What about 1000 to calculate the concentration gram per liter? Then 1000 multiplied by 10 gram, then divided by 250. Then you'll get 40 gram per liter. 40 gram per liter. That's how you do it, but B. But C, the concentration of solution A, why am I always forgetting? The concentration of solution A in moles per liter, where potassium is 39, manganate 55, oxygen 16. So how do you calculate that? Then concentration in moles per liter means molarity. Molarity can be obtained. Molarity is equal to concentration gram per liter over RFM. So you have already concentration gram per liter here. We have gotten in part B. So how do you calculate RFM? We need to calculate RFM. RFM of potassium magnate 7, where K, which is potassium, is 39. Manganate Mn is 55 because we have here 55 and here 39. Okay, then oxygen O is 16. And we have here 4 oxygen. 4 times 16, you will get 64. So you take now 39, then plus 55, which is manganese, plus 64, which is 16 times 4, which is oxygen. When you add all of them, you will get 158. Then therefore molarity is equal to concentration gram per liter, which is 40, divided by the RFM that we have obtained, 158. Then our molarity is here. Sorry, here is not mole. Here is not mole, it is M. It is M. It is molar because it's molarity. You can make it molar, eh? So you can use the other pen. Here is M, not. Here is 0.25 molar, not moles, eh? Okay, that's how you calculate part C. Part C, what have we done it? We have calculated the RFM, then we divided the concentration which we have obtained in part B. So we have part C. That's how you calculate part C. Eh? We have part D, the number of moles of solution A used. The number of moles of solution A used. To calculate the number of moles of solution A used, we have the volume of solution A used as a 15 centimeter cubic, which is the average volume. We also have the molarity here. Then we can say molarity is equal to 1000. 15 is equal to how much? Let us see part D in the next page. 0.25 is equal to 1000. What about 15 centimeter cube? 0.25 is the molarity of the acid of the solution A. is the molarity of solution A, which is 0.25 is equal to 1000. What about the average volume? 15. So 0.25 is equal to 1000, molarity 15 centimeter cubic. How much? Then cross multiplication. This one you multiply this one, which means 15 centimeter cube times 0.25 divided by 1000. Then you'll get 0.00375 moles of solution A used. This is the number of moles of solution A used. Okay, we have part E. Part D we have finished it. Part E, the mass of the sample of the solution A. The mass of the sample. How do you get mass? How do you get mass? And by the way, what is this mass they are telling us? We have already the mass of solution A. What is this mass that they tell us? The mass of solution already is 10 gram. What is this mass? This mass they are asking now is the amount of mass used. All 10 grams of solution A is not used. Only they are asking you the amount of mass used. That means we call it the mass of the sample. Sample means the amount of the mass used only. That means even the question is asking used. So how do you calculate it? You can calculate by saying that this is the volume used. This is the number of moles used. The number of moles used, then you multiply the RFM, then you get the mass used. Mass is equal to number of moles times RFM, or molar mass. So the number of moles used is 0.00375, which is this one, times the RFM, which is 158, the RFM that we have obtained for potassium magnesium solution A. So this is the mass of the sample, the mass of the sample. Okay, next question is asking the percentage purity of solution A. Percentage purity of solution A. How do you calculate percentage purity? Percentage purity can be obtained by using this formula. Percentage purity is equal to mass of the sample, which is this one, divided by the total mass times 100%. So mass of the sample, we have it here, we have obtained it right now. This is the mass of the sample. Okay, we know that. Okay, where is our total mass? The total mass of solution A. Let us check it from the question. So the total mass is 10 gram of solution A. It's 10 gram. So therefore, this is what we do. 0.5925, which is the mass of the sample, or the total mass, which is 10 gram times 100%. You'll get 5.9. You round it 6%. 6% is the mass, is the percentage. So to get the percentage purity, 100 minus 6. So 95% of the compound is pure. 95% of the compound is pure, where 6% is impure. So that's what you do in part F. So we have also another question. F, that's what you do. F, we have done it. But G, the concentration of solution B in gram per liter. The concentration of solution B in gram per liter. So solution B, now we have finished solution A. Let us go to solution B. Solution B, the concentration of solution B in solution B. What do we have? We have the mass 8 gram, we have the total volume 100. Then we can calculate this one. Very simple. 8 gram is equal to 100. Total mass, what about 1000? Simple. 8 gram is equal to 100, the total volume given. Then what about 1000? Then you cross multiply. Then 8 gram per liter. This is the concentration in gram per liter. The next question is asking, that's how you calculate concentration in gram per liter. The next question is asking concentration of solution B in moles per liter, given that this compound FO2, which is ferrous iron 2 sulfate, ammonium sulfate, and water molecules, 6 water molecules. So how do you calculate that? We are given iron is 56, nitrogen 14, hydrogen 1, oxygen 16, sulfur 32. Obvious. How do you calculate? How do you calculate concentration of solution B in moles per liter? So this is what you do. So first, molarity is equal to concentration, means molarity is equal to concentration gram per liter over RFM. Our concentration gram per liter, we have already obtained it here. Then we have to look at the RFM. RFM of ferrous iron 2 sulfate, ferrous ammonium iron 2 sulfate, 6 molecules of water. The RFM is 392 when you calculate it. We have done it before. So therefore molarity is equal to 80 gram per liter, which is the concentration, divided by the RFM, which is 392. Then this is what you get. This is now our molarity of solution P. Molarity of solution P. Very good. Then the next question is asking, question I, the number of moles of solution B used. To get the number of moles of solution B used, you have the volume of solution B used. So the volume using a pipette 25 centimeter cube of solution B in a clean conical flask. So this is now the volume of solution B used 25. We have already obtained the molarity in part H. The molarity of solution B is 0.21. Then this is what you will do. 0.21 is equal to 1000. What about 25 of the volume used? You do cross multiplication. 25 times 0.21 divided by 1000. Then when you multiply this one and this one, you divide 1000 and you use the calculator. This is what you will get. So this is the moles of solution B used. So part J is very simple. Part J is asking the mole ratio of A to B. Very simple. The mole ratio of A to B. Do you have the number of moles of A? Yes. Do you have the number of moles of B? Yes. We put in this form, in ratio form, then we simplify to get the mole ratio. So let us see that one. This is the number of moles of solution A, which is 0.00375. Then the number of moles of solution B is 0.0052. So to get the mole ratio A to B is equal to 0. The mole ratio of A, already I said, it is this one, 0.00375, which is here, 0.00375, to the mole ratio of B, which is 0.00525, which is the number of moles of solution B. Then you look now the smallest value here and here. You compare these two moles, the moles of A and the moles of B. You compare it. Which one is less value? So here we have 0, 0. Then next, the third value is 3. And here we have 0, 0. The third value is 5. And 5 and 3, when you compare, 3 is less than 5. So since 3 is less than 5, this value, which is 0.00375, you divide both sides to simplify. When you divide both sides here, you'll get 1. When you divide this one to this one, when you cancel this one to this one, you'll get 1.4. 4, therefore, you round off. Then you will get 1 here and here 1. So the mole ratio is 1 to 1. I hope you have understood it. This is the question that can contain mole ratio. It can also contain percentage purity. It's different from the other question of Redox that we have done it. The other question of Redox that we have done it was only asking the mole ratio. But this one contains both mole ratio and percentage purity. So this one is phase 2. We have phase 3. Our next is we have phase 3. So please make sure you subscribe my channel, and also you ask me if you have any question and you write in the section, especially in the comment section, so that I will answer any question that you have. Thank you.